Welcome students to your channel Producer Classes as PSC where logo can talks the physics, and today we are in IIT Foundation course. This is ICSE-10, and as I promise it will be a numerical class on circular motion, and it is all about F equal to mv square by r, and what is v, what is I, r, and what is the value of F. So this is obviously it is a centripetal force. And what is centripetal force, what is centrifugal force, I discuss all the topic related with the previous video. So if you are first in that particular class, then go back to the previous one and enjoy the new numericals as well, the concepts given for particular one, that is chapter 1, and then again join. Okay, so let's students start with interesting numericals, as the last one is a better numerical, as I say, and it is you can think that particular numericals. Okay, so let's start with the first one, and take your habit as first of all write down the numericals and try, and then pause the video and try again, and then see the answer. So students, and you can also follow, and your elder brother, if they're one, then they can follow the concepts of 11th, 12th, and the different series are also given. There is numerical king series. It is based on the numericals based on 11th and 12th standard, as well as there is another bombasting series. There is a classic text series that is based on Erudov solutions and is a more empowered numericals. All are given that particular series. So follow that particular series one, and if you think that this is the best numerical channel, and then you can share with your friends. Okay, so for the first one is the question number 1, and I repeat again, students, if you are first, then when a body moves in a circular path, then if this is the radius, then it always moves with a constant speed, not velocity, with a constant speed, and the velocity changes at every point on the circle, since its direction is changing, and the velocity is a vector quantity. So its direction changes at every point on the circle. So a particular body moves around a circle with radius, making a radius, then always a force is required to move that particular one. If we try to move a particular body, then you have to apply a force. Similarly, if you rotate a particular object, a particular point object, then you have to apply a force, and this is called Fc. So this is named as centripetal force. And this centripetal force is proportional to the mass of the body. If the mass of the body is more and more, then you have to apply a greater amount of centripetal force. And if you want to rotate this one with a greater velocity, then you have to also increase your centripetal force. And if it is a small radius, then the force is also greater. So this is the inverse relationship. This is directly and this is also directly proportional, and the formula is F equal to mv square by r. So this is centripetal force. Students, think about you want to rotate a particular body with a circular one, then you have to apply centripetal force to continue this rotation. Okay, so it is this accelerated motion, not a constant velocity or uniform motion. So it is an accelerated motion, and if you want to rotate a particular one, then you have to apply Fc equal to mv square by r. So the numerical is based on that particular equation, mv square by r. First of all, students, write down the numerical, and then find out the numeric value. That is given the mass, the velocity and radius, and then substitute with this particular equation and you get the answer. So the first question is a stone of mass 50 gram. So the mass is given, this is 50 gram, mass is given 50 gram and tied to one end of the string. And student, it is more interesting than if you pause the video and calculate that particular numerical one, and when I solve this, then you can check the answer, and that will be more interesting. So it is the mass equal to 50 gram is given and end of the string is rotated in a horizontal circle. Why it is not vertical? Because if you rotate along this direction vertical, then mg act at every point, and that can influence your rotation. Okay, so this is horizontal rotation, so at each and every point the gravitational pull is same, so you can neglect this one. So it is a 50 gram tied at one end of the string and rotated in a horizontal circle of radius 1 meter. Yes, so it is given 1 meter is the radius, 1 meter is the radius, and the speed is 5 meter per second, so it is also given 5 meter per second, 5 meter per second, and calculate the centripetal force. So m equal to 50 gram, so 50 divided by, it is gram, so you have to divide it with 1000, since 1 kg equal to 1000 gram. Okay, so well, next the velocity, so 5 meter and 5 square equal to 25 mv square by r. R means it is 1 meter, 1 meter. So the answer is 525. There is 75. 5 into 25, 125. 5 into 25. So 0 cancel this one, and 5 into 25. 5 halves are 5, 5 2s are 10, and then 20 divided by 100. So it is better to, this is 1.25. 125 divided by 100, that is 1.25 Newton. So this is the amount of centripetal force. And a student, if I if you think that this is not the correct answer, then you can comment on that particular comment box. Okay, so I rectify myself in the next class. So the next one is question number 2. So the next one is question number 2, and this is, yes, it is a big one and it is more conceptual part. An electron of mass, this is moving around a proton of radius this one with the speed of v, and centripetal force between them is with the speed v. Centripetal force between them is given by this equation, where q equal to this one. Then calculate the speed of the electron. Okay, so students, first of all you have to calculate the centripetal force. You have to calculate centripetal force, because the equation is given 9 into 10 to the power 9 into q square. So q is also given, so this is 1.6 into 10 to the power minus 19, and this is a square divided by r square. So 1.53 angstrom. Angstrom means 10 to the power minus 10, since 1 angstrom is equal to 10 to the power minus 10 meter. So this one in q square by this is r square. So this is the value of Fc, centripetal 1. So this is the value of centripetal force, and you have to calculate that particular numerical. So you have to multiply 9 into 1.6, and this is a square, so you have to write again 1.6 by 1.53 and 1.53. So it is a big calculation. And then the power is 10 to the power 9 here, and here is minus 38, this is minus 19 square, and here it is minus 10, so 10 minus 20, and when it comes in the numerator portion, so this is plus 20. So this is the zeros calculation of the power, and this is a numeric value. This is the numeric value, and it is this one, and I can take a help of calculator. I can take a the help of calculator one, and you can also calculate with multiply. So it is 9 into 1.6 into 1.6, and this is equal to divided by 1.53 divided by 1.53. Okay, so this is 9.8. So this is 9.8 into 10 to the power of into 10 to the power of, this is 29. So 38, and you have to subtract this one 9 and this is 20, so 29. So this is 9. So this is 9 minus of 9. So this is 9.8 nanonewton. This amount of force act where it is act. So next, this is 9.8 nanonewton. Okay. So the next one is, here comes FC is given, that is 9.8 nanonewton. And there is a proton and there is an electron. There is a proton and there is the electron, and the distance is given also, and the electron is moving with the velocity v. So FC is calculated, and this is mv square by r, and you have to calculate v square, the velocity with which the electron rotate in an atom. So v square equal to FC is given, that is 9.8 into 10 to the power of minus 9 into radius. Radius is also given, and which is 1.53 angstrom, that is 10 to the power of minus 10. Fc into r divided by mass is also given, 9.1 into 10 to the power minus 31, and you have to calculate velocity. So this is root over of this one. So this one is 9.8 into 1.53 divided by 9.1 divided by 9.1. This one into this one divided by this one into 10 to the power minus of 9 into minus of 10 and plus 31. This is 31. So this is the final answer. So again I take the help of calculator, and this is 9.8 into 1.53 divided by 9.1, and this is equal to 1.65. Approximate value, this is 1.65 approximate. So v equal to root over of 1.65 into, and you can take a root of this one. So this is 19 and 31. This is 31, and you can subtract. This is 19. So 9, 2, and this is 2. This is 1. So minus. So plus 12. Plus 12 means 6. So this is the root into 10 to the power of 12 means 6. So this is root over of this answer. So root over of the answer, this is equal to 1.28. So this is 1.28, or approximate we can write as 3. So 1.3 into 10 to the power of 6 meter per second. Students, if I calculate a wrong calculation, then you can check this one, but the concept is this one. Okay, the concept is this one. By mistake I also make a wrong calculation. So the next numerical is, so again students, write down the numerical. An aircraft execute a horizontal loop of radius 1 kilometer. So r is 1 kilometer. R is 1 kilometer, and with a steady speed is given. So it is also given, that is 900 kilometer per hour. This is kilometer per hour, and compare it centripetal acceleration with the acceleration due to gravity. So what is the centripetal acceleration? And you have to, this is Fc equal to mv square by r. mv square by r. So here you have to compare this one with a force, that is gravity force, and the gravity force is mg. The gravity force is mg. So you have to compare this one with a gravitational force or gravitational, and the next answer is it equal to the ratio of the centripetal force to the weight? So yes, it is equal, because if mass and mass cancel this one, So force equal to mass into acceleration, so the acceleration is v square by r. So this is called centripetal acceleration, and this is v square by r. And if also this can divided with mass, then it gets a g. This is acceleration. So g is the gravitational acceleration. This is 9.8 meter by second square, and this is centripetal. You have to calculate this one. So velocity is given 900. So 900 into 5 by 18 meter per second. So this is 50 and 250 meter per second, 250 meter per second, and 1 kilometer. That means this is meter, 1000 meter. So v square means 250 into 250, 250 into 250 by radius is given, and this is 1000. So 0 0 0 0 cancel this one. 5 5 ja 25, and this is 5 2 ja this one. So 5 into 25 by 2. So the acceleration equal to 25 into 5 by 2, and g is 9.8, or for easiest calculation you can take as 10. So if I take this one as 10, so this is the ratio. So centri by g is equal to 5 to 25 by 4. So this is the ratio. Okay, is it equal? You have to compare aircraft of this one with the loop of this one, and speed is this one. Compare its centripetal acceleration with x. So you have to just compare with it, and you can also calculate this one, a numerical value, that is 6.25. So this is the answer, 6.25, or you can simply written as 25. But the next one, this is question number 4, is more interesting, and this one is, and one day you think that you want to rotate your brother or sister playfully, and you and your brother or sister within a ground or within your room, within your verandas, and you want to rotate with your sister with your hand, with your muscle power, with a speed is given. There is 0.5 meter per second, and your weight of your sister is 40. Like that, you hold your sister and rotate this like that, and this is also a circular motion. So you have to calculate the centripetal force required for it. So it is a relative numericals, and this numerical can realize you with a better concept. So one day you think that you want to rotate your sister or brother playfully, and what amount of centripetal force is required to do this, and the length of your hand is given. So the radius is given. Length of your hand means your radius is given, and this is 50 by 100. So this is half meter. So this is half meter, and m is given. Mass is 40 kg. Mass is 40 kg, and then velocity is also given. So this is 0.5 meter per second is given, and the students, and I think you easily calculate this one, since it is mv square by r. So m equal to 40, and v square is 0.5 into 0.5 by r. So radius is half meter. So half, when 2 takes into account, then it goes into the numerator portion. So this is 40 into 0.5 into 2 into 0.5. Okay, so 5 to the 10, and this one is cancelled. So this is 1, and this, if 0 is cancelled due to this point, then 20. This is 20. So 20 Newton. So you can, students, you can easily take a feelings of 20 Newton force with your sister and brother, and take him and try to rotate this one, and don't do that but playfully. Okay, so you can I think you realize all the numericals related with the circular motion, and it is the basic concept, and you can elaborately explain with the concepts 11th concept, because there is a chapter of circular motion in 11th standard. So I want to feel you like some numericals, like some concepts, and it is in your textbook, so you have to write. And I think your concept is growing with this channel, so stay with me. And last of all, students, you can share with your friends circle this channel. I think this channel can help you. Okay, so thank you, and last of all, continue your study. Okay.